Hi, welcome to our presentation. We're students at Concordia right now, and this is a presentation of our Capstone project. Our Capstone project was about Common Core and the 4 C's of 21st century learning. I'm Navaz Kerawalla. I'm a high school math teacher at Trevico Hills High School.
And I am Angie Rumsey, and I'm a 3rd grade teacher at Salem Lutheran School.
Okay.
All right, so students struggle with word problems, and here's a kid who's saying, I struggle with word problems, and I may know my math facts, but when I am presented with real world situations, I don't know how to find the answer. I also need to be ready to solve real world problems when I go to college and when I get a career.
So at high school level, it's not just about the word problems, it's about getting students ready for after high school. And they're going to face real world problems to either be in college, and if they don't go to college, they're going to face problems in careers that they need to be able to solve.
So, as you all know, the Common Core has been adopted by 43 states, and with the adoption of the Common Core, teachers are asked to, it's been impressed upon them that they need to shift the way that they present their information, developing a technology-rich environment. The Common Core serves as a guideline to ensure that our students are ready for college and career upon high school graduation. So, students need to have a good balance between knowing their basic skills in math and being able to then apply those in real life. And with that, we have come up with 2 questions that we need to answer for our study.
The first one is, in what ways does the incorporation of math practices of Common Core and the 4 C's on teaching methodologies and student in-depth learning?
And our second question was, what effect does technology have on teaching methodologies and student achievement? So before we get started into the study, we're just going to tell you some terms that we use throughout the study. CCSS stands for Common Core State Standards.
Digital natives means these kids have been born into technology. They've had some devices that they've had access to ever since they were infants.
And a digital immigrant is someone who is adopting technology and making it a part of their everyday lives.
Flipped learning is about flipped lessons, where they watch lesson videos at home. They come to school with questions and answers and do their assignments in class.
And the 4 C's are communication, collaboration, creativity, and critical thinking. So let's talk a little bit more about where the 4 C's came from. Let's also talk about where Common Core came from. A team of experts from Association of Mathematics Teacher Educators, Associate of State Supervisors of Mathematics, the National Council of Supervisors of Mathematics, and the National Council of Teachers of Mathematics created the Common Core State Standards. The National Education Association established the Partnership for 21st Century Learning in order to identify the most essential skills that students will need to be 21st century learners. And they narrowed those skills down to 4. Collaboration, communication, critical thinking, and creativity. So just some fun facts about the Common Core. 43 states have adopted the Common Core. California's standards, before they adopted, were 15 years old, so they were ready to be revised. The standards are written with a backward design, so they start with high school, and they go backward, and they think, what do kindergartners need to know incrementally until they get to high school and graduate. And the ultimate goal is that the Common Core standards prepare students to be college and career ready.
Before we start that, I want to talk about why we need the Common Core. Why wasn't the old standards good enough? We grew up with it, right? But students lack depth of knowledge. They know how to do a problem, but the question why? Why do we need to do this problem? They skimmed the surface with procedures, 3 times 5 is 15, but how do I apply that later? Or what the real problem is, where they can use these skills. So Common Core addresses that situation.
Hello. Welcome to Energy Conservation Incorporated.
Thank you. I really hope to get a job here.
Well, let's get started with your interview. What do you think are your greatest strengths?
My greatest strengths.
Yes, your greatest strengths.
What are my answer choices?
What do you mean?
My answer choices. You know, A, B, C, or D.
There are not any answer choices.
Oh, I understand. In that case, I choose C.
You choose C?
Yes, I choose C. My 5th grade teacher told me to always choose C when I did not know the answer.
Oh, it sounds like your 5th grade teacher really prepared you for your future. Moving on then. This job will require you to write proposals about energy conservation. Are you a strong writer?
Yes. My teachers always told me that I write very good stories. I also like to write poetry.
Well, we will not need you to write poetry or stories. We will need you to write proposals regarding energy conservation.
Proposals. Is that like writing a persuasive essay?
Sure.
In that case, yes. I am very good at writing proposals. Every year in school, my teachers made me write a proposal regarding school uniform policies. I also wrote some proposals about banning cell phones in school. Would you like to read them?
No, I would not like to read them. If you get a job here, you will need to write proposals about energy conservation. Your proposals will need to include basic mathematical equations as well as scientific research.
Wait.
What is wrong?
I am confused.
That is not very surprising.
You said I would have to include mathematical equations and scientific research in my writing.
Yes, that is what I said.
But that doesn't make sense.
What doesn't make sense?
Math, science, and writing. They are separate subjects. I don't know if I can incorporate math and science into my writing. They are all very different.
Well, if you work here, that is what you will have to do.
This job seems very difficult. I do not think my public education prepared me to work here.
Well, I have to agree with you. I have one more question for you though. Why did you think you were ever qualified to work here in the first place? Why are you looking around?
You asked me a question, and I do not know the answer. So, I am looking for someone to think, pair, share with.
There is no one for you to think, pair, share with.
Oh. In that case, I choose C.
I think I've heard enough. Thank you for coming in.
Okay. And this conditioning with students taking multiple choice tests is where I'm at high school. It's going to be a hard habit to break. So we are waiting for the wave of 4th, 5th graders to come through to really see what Common Core will do.
So the Common Core is actually divided into 2 sections. You have your content standards, which are your typical standards. What does the student need to be able to do? 3rd grade example is, be able to multiply or know the unknown number. Then there's mathematical practice standards, and those are the same kindergarten through 8th grade. They're the same 8 standards. Practice standards. One example is that students would be able to make sense in problems and persevere in solving them. So, looking around, think, pair, share is not meeting this practice standard.
Content standards for high school, they're broken down into Algebra 1, Geometry, Algebra 2. And further on, they will be having standards for pre-calculus and calculus. But the math practice standards, they are the same practice standards that are from kindergarten to high school, all the way. Because these standards are the skills that we need to instill in these students. They need to learn to think abstractly, to think why they're doing something, be able to argue their point, be able to defend their point in how they will do their math. These are the practice standards. They are broken down into habits of mind, making sense of problems, attempt to precision. The other one's reasoning and explaining, modeling and using tools, seeing structure. All these are the same standards, whether they're in kindergarten or in high school. Some of the elementary math practice standards, making sense of problem and persevere in solving them. We can teach them math facts, 3 times 5, 15, but let's show them books, 5 books, they're $3 each. That will stick more than memorization. But there is a place for memorization for facts. They need that. But go beyond the facts is what we're trying to achieve. And making connections with real world, again, showing them how they can use this, or helping them with their trips with their parents to a grocery store. They will use math, it's all around them. Participants, your students?
I used my 3rd grade class, all 15 students, and all parents signed permission forms. I have one student who is released to a resource teacher, but was not released for the intervention.
Okay, I have 2 classes in geometry. There are 80 students. 31 brought the permission slip back, so they're the ones that participated in my study.
All right, so we had to review literature that had to do with Common Core and the 4 C's and technology.
Ken Robinson is an amazing educator, inspirational speaker. And he's got videos on TED. Do you know TED Talks? Really very inspirational. He believes that we have taken creativity out of our education. Students are most creative in kindergarten, 1st grade, 2nd grade, 3rd grade. We start feeding them instructions, and they stop thinking. And by the time they get to 9th grade, high school, they're just waiting for you to tell them what to do. You tell them to solve a problem, find a way to solve it, they are lost. There's no creativity to think of different ways to solve a problem. And he's a proponent of introducing the arts, music back into the curriculum, because those disciplines help with math scores. So instead of just going science, technology, he wants to reintroduce arts back into the curriculum. Marilyn Burns is another one. She has a website where students and teachers can learn how to solve problems. She sits down, she still teaches little students. Her strength is 1st to 8th grade, and she indicates that we as teachers, when we call students for answers, as soon as we hear a correct answer, we stop looking. If the first student gives us a correct answer, we go to the next question. But she says, stop and listen to them. Listen to what methodology they use. How did they get to the answer they did? How are they thinking? Not the answer is what's important. Guide their thinking to the right place instead of just an answer. And Mark Prensky is a are a big proponent of technology. He seems to agree that students should use any and all technology available for their education. And teachers are partners with them. We are working together with them. That we guide them what they need to learn, but let them learn how to use it and how they get there. Career and college and career readiness. Students transition from elementary to middle school. They know where they're going, they know what they will learn. Middle school, high school, same thing. They have the same English, math, science. They will learn that. But where do they go after high school? That's where our job is important, because not everybody goes to a 4-year school. Some will go to a 2-year school. Some may not be able to go to college or may not want to. But in high school, that's where we need to get them ready to face whether they go to a 4-year, 2-year, no college. And they need to be ready to solve problems. And as we know, our global economy's shrinking. Outsourcing jobs has become very common. So when they do go into a career, they're going to compete globally. And they're competing for the same jobs that somebody in India or China will compete for. So they need to be able to stand up and be ready for that.
So the benefits of collaboration in a learning environment, educators need to become more like coaches, like she was saying. And that means that we need to get the kids together talking about math and talking about their thinking, and we're standing back and we're listening to their conversations. Teachers need to be more cognizant that they are actually engaging their students in math thinking, and that when students talk to each other, while they're working on tasks, they need to be talking to each other. So collaboration is really important in any kind of instruction. Again, critical thinking is a skill that needs to be incorporated into every lesson, math lesson. Specifically, looking at real-world problems. Students need to be exposed to real-world problems as opposed to worksheets that are just full of equations and algorithms. Teachers often teach by using rote memorization and algorithms and formulas, and this does not teach students how to use their critical thinking skills in math. Sosa, and the author of How the Brain Learns, argues that routine activities that focus on just answers are superficial and disjointed, and therefore make retention difficult. Information must make sense in order for retention to occur. Communication is extremely important in the learning environment. While students are talking about their thinking, like I said before, the teachers can be listening and getting information as to what the students know. Going beyond that, students being able to articulate what they're doing, whether that be verbally or in a math journal, writing it out, is an important part of the communication part of the 4 C's. And when we think of creativity, sometimes we think of, drawing or writing music or something like that. But being able to look at a problem and find a creative solution to it, we can all come to the same answer, but we have to understand that kids come to that answer in different ways and different paths. She said earlier that the kindergartner is still being creative about the way they solve their math problems. But really by 3rd grade, which is what I teach, they want the algorithm. They want to know, what do I do? And even if I put the equal sign in a different place, they're confused because they've already been conditioned to, this is what adding looks like, or this is what subtracting looks like. So as Robinson says, we need to get creativity even back into the math classroom. And I believe that technology is at the center of the 4 C's. I like this cartoon. It says, due to recent technological advances, everything I taught you about computers is no longer valid. And, you know, it's the challenge of the teachers to stay up with what's going on with technology. In fact, a lot of teachers think that they are being innovative, and they think that they have their technology and they're doing what they're supposed to be doing. But often they have just reverted back to old ways. And the researchers say that the way that you can get teachers to keep up with technology is rewards and accountability. There needs to be constant teacher training, and that's a big part of the technology piece. The researchers also say that innovative tools, computers, iPads and such, do not shift teacher pedagogy. Teachers who think they are innovative are often reverting back to what they've always done. So they continue to report that teachers must receive continual training and be held accountable. One example that you've probably heard of is Khan Academy. Critics say that Khan Academy is just another output program, and it's reverting back to what teachers have done all along anyway. And in many ways this is true. So that would be an example of a teacher reverting back to just the old way of teaching. It's technology unchecked. So the tool alone, Khan Academy, didn't shift the teacher pedagogy. However, the vision of Salman Khan, who is the creator of Khan Academy, is to put the student in the center of their own learning. So it may need some changes and some shifts, but it has a good heart to it. The other thing that Khan Academy has done is inspired teachers to actually create their own math videos, which I will talk about a website a little bit later of some math videos that I showed my class. All right, our interventions. To start our intervention, we needed 3 forms of validity. So we chose outcome, transferable, and catalytic. And the confidentiality included our school principal signing an informed consent. Parents and students also signed consent and assent forms. I'm going to talk about my intervention, and then Navaz is going to talk about her intervention. So in order to answer my primary and secondary research questions, I implemented a 3-week study. I wanted to see what kind of an effect the 4 C's in technology had on student perceptions of word problems and their success, as well as my own teaching methodology. I also wanted to compare a direct instruction and worksheet-centered approach to a 4 C's in technology approach. So I administered a survey, and I pretty much asked them to rate how they felt about word problems, how they felt about working in groups, how they liked to display their learning, whether it be a project or a test, and what they felt about their writing and math. For about a week, I taught division, and they had not been exposed to division yet. They had been exposed to multiplication, and many of them kind of knew that they were related. I used a direct instruction approach, and I gave worksheets. The worksheets mostly had equations on them, and at the bottom there were always a couple of word problems, but they always required division. So the kid knew he was doing a division worksheet. He knew to take those numbers at the bottom and divide. And as you will see in the findings, they did pretty well. After a week, I then implemented a, let's go back a slide. After I gave them the week of worksheets, I gave them a test. The test was a 10-question word problem test. And because they had already done add, subtract, multiply, the questions were a variety of operations. So they had to determine, do I add, subtract, multiply, divide? Then I incorporated the 4 C's and technology, and I did this for 2 weeks. We made a digital math journal in Google. I showed them videos that I had created about division. There's a online resource called Learn Zillion that has math videos, how-to math videos. Students still worked on their fluency in Extra Math, which is a flashcards program on the computer. Another program called Front Row gave them word problem practice. They also participated in hands-on activities, such as just taking a bagel and dividing it up, taking a little cup of Skittles and dividing it up. My students have to read books for our reading program, and if they have a 250-page book and they need to read it in 7 days, that's a division problem. So I taught them how to use a calculator on their computer, which I actually taught them how to use Spotlight as a calculator. They thought that was pretty cool. And then to kind of put it all together, they had to create their own movie in iMovie, and they had to display division in a real world situation. So some of the tools we used were Extra Math, Front Row, Photo Booth, iMovie, and Google Drive. How did they collaborate? When they were dividing up their Skittles, they worked together in groups. Students worked together to create their iMovie and division project. So that was how I used collaboration. The communication was evident. There was one day where I had them actually just talk about how they could use the Spotlight as a division tool into Photo Booth. So that was a form of communication. And I showed all the videos to the class. So even as I showed someone's video, they could kind of talk about what that kid had said. And then they showed their learning through the iMovie, and then also they wrote about their math thinking in a digital math journal. Here is one of my students talking about how she can use the Spotlight as a tool.
Hi, today
She also used an effect, so it gets a little creepy, but it's kind of fun.
I'm going to explain how you use math while you're reading a book. So you have to write a table and write the title of the book, the pages of how many pages are in the book, and how many days you want to read it. Then you go in Spotlight and do a little slash, and that slash stands for division. Division just multiplies it and helps it do it. The tool is easier than doing multi-math because it gives you the answer. I gotta go. The teacher said gotta go.
She said the tool is easier than using mental math. That's what she said. So critical thinking, they had to apply, especially in the division movie, they had to really think, is this division? When they were dividing up the bagel, they were using critical thinking skills, figuring out their goals for their book, and especially creating the scenarios. Students were active in conversation and actually argued. And that was healthy, that was good, because they were trying to argue their point, and that's critical thinking. The math ideas were the focus, the ideas of division were the focus rather than the algorithm or the equation. And the students wanted to make sense of the problems. As I was showing the teacher-created videos, the Learn Zillion videos, often I'd have to pause the video and they would, wait, what about this or what about that? And so there was much more conversation than when I was doing worksheets. All right, these kids are trying to divide their Skittles, and there's 3 of them, and they're trying to divide them, and they're just getting confused. And so here's a little video. So do that.
We tried it. They all got different numbers, so I just put one back.
Okay, try it again.
They're like, wait guys, we have to have 3. And just put, guys, this isn't gonna work.
Stop. Now, why do you think it's not gonna work?
Because we're all one person just needs to go like that.
Okay, I think she's right. I think you have to have one.
Now I'm
person
gonna walk
do it.
over to another group and you're gonna hear them.
And maybe after a while they can take a rest and the next person can go. And then you can share the job.
And I left that in there on purpose.
Actually help here.
Don't you made the Skittles all fall.
Well, guess what?
So now they're gonna.
All right, so the collaboration is going on there also, and one of the 4 skills that they say they need is to be able to collaborate, and so it's really important that we're teaching kids how to do that. And evidence of creativity would be that students were exposed and allowed to solve things their own way, even just dividing up the Skittles. First, some of the kids wanted to count how many they had. Other kids said, no, let's just start by putting them in 3 groups. Making their division scenarios was definitely a big part of the creativity process. And I'm just going to show you a piece of, this is one of their movies that they made, and I'm just going to show you a piece of it. Oops. Hit the wrong button. They're kind of silly. Part of it.
Anyway, let me explain for those of you who don't get it.
Now she's going to say 27 times 3, but she means divide. She really, really does.
27 times 3 equals 9. 9 times 3 equals 27. Yes, division is multiplication backwards. That's why teachers tell you gotta memorize multiplication. Because you need it to help you with division. It's also a fact family, for those of you who don't know. Once upon a time, in a place that did exist, a girl named 2 stars in that part of the hamburger scene. Boogie.
So this group they had to do 3 scenarios, and each one took a scenario. So now we're going to watch the next girls.
At that parties, Jen invited 3 people to a birthday party. Her mom got a box of 15 cupcakes. 15 divided by 4 is... Let's divide! You can't get to 15 by counting by 4s, so we use remainders. First we find the closest number to 15 counting by 4s. 4, 8, 12. 12 is the closest number to 15 counting by 4. 12 divided by 4 is 3. So 15 divided by 4 is 3. 12 is less than 15. We need remainders. Since 12 plus 3 equals 15, the final answer is 15 divided by 4 equals 3 with a remainder of 3.
Okay. So she even included remainders. And as we were doing the dividing the bagels and dividing the Skittles, they were like, there's leftovers. So something that would not have even come up in a worksheet came up, and I believe that they understood the concept. The students wrote in a digital math journal using Google Drive, and at the end of the study I gave them another 10-question test, all word problems. They were a little different, and I gave them a survey. And that was my intervention. Now she's going to talk about her intervention.
Okay, my intervention was in my geometry class, and it was a unit on quadrilaterals. But before we start with quadrilaterals, I have to introduce them to just the concept of polygons. And I started with a brainstorming activity. Throughout this intervention, they all worked in groups. Group of 4, which I made up the groups because at high school they just want to be with buddies, and that doesn't work every single time. But I grouped them in heterogeneous groups. There were different levels of students in each group, mainly so they can also help each other. They were a little unhappy about that, but that's what worked. So we started brainstorming about polygons in general, and I used a lot of self-discovery lessons, which the words in blue are the math practices. I used collaboration communication. Yes, they were talking to each other all throughout the activities. They were communicating, sometimes very strongly opinionated, but they were arguing their point, and they had to prove that they were right or not. And we did constructions. Constructions are a big part of geometry. And I saw there were students that were helping out their group. And I had never grouped them before, and this was really something I did it as part of this intervention. And I've left those groups for 3 weeks now, and it's worked really great. Review activities, again, we did as groups. Their scores were much better on a test. Peer evaluations, they had to trade their homeworks back and forth to grade them, not grade them, but just to see if they did it right. And if they didn't, they had to ask their group first before they asked me for help. And that worked really good. Peer tutoring, again, they're helping each other out a lot more. They speak high school math. I am just barking. So, critical thinking, of course, it goes on all the time. It was great using the flip lesson. I did not make my own videos this time, but I was able to find some really good videos on YouTube about parallelograms, about kites and trapezoids. And they had to watch these videos at home, take their notes, do their diagrams, and the next day come and ask me questions about it, which was eye-opening because they wanted to get started on their homework, but I had to evaluate what they learned. And so I was questioning them, and I could tell they had paid attention. Some of them had to watch it a couple of times just to get it. So the flip lesson idea worked. Finding patterns, quadrilaterals have, like parallelograms, rectangles, squares, they have a lot of similar attributes. Their lines are parallel, they have 90-degree angles, their diagonals are, some diagonals are congruent. So they had to find patterns and similarities, and which quadrilaterals come from other ones. Like squares, they would be similar to rectangles and parallelograms. So another thing I did was a writing prompt. They had a parallel line transversal unit in the first semester, but that was another big point when they start thinking about parallelograms and to make those connections. So they needed to write about those connections and give me diagrams and make sure how they learned it. Okay, creativity, they had to use PowerPoint, Google Slide, take pictures in the world around them. Nothing downloaded. They had to find images outside my classroom and identify what quadrilaterals they were. Give me diagrams, give me properties, give me what you find, and it's all around you. To make those connections, they have to see what was outside their classroom. Technology I use for flip lessons. One of the applications is called EduCanon. It loads a video, and at key points you can pause it, you can introduce questions. Students have to answer those questions and then move on. It was a useful tool. I used another flip lesson with a QR code. Instead of being tied to a computer, they could watch the video on their phone. They just had to scan the code. The video would come up. They can do their lesson, their questions. They didn't have to be next to a computer. Of course, PowerPoint, Google Slides presentation. I got many creative results on that one.
All right, so we triangulated our data so that we could compare our information. Both of us gave tests, we both gave a survey, and we both kept a journal of our observations. So this is how my survey turned out. The blue is the pre-intervention and the red is the post-intervention. And the question was solving word problems in math is easy. So there's an increase after the intervention that they felt nicer about solving word problems after the intervention. Interestingly, they have a lot of confidence in this class. Nobody put disagree for either one. So it's a very confident class. I enjoy solving word problems in a group was a little different. The amount of students which disagreed with this statement indicating that they don't like to solve word problems in a group increased. And I attribute that to the fact that maybe it was something that they're just not comfortable with, and they had to work and collaborate. So that's something that they need more work on and more practice with. I found it interesting that that more kids said that, or that less kids said that they agree with it at the end of the intervention. The next question was, how do you prefer to show your learning? And in both surveys, they would prefer to show their learning using a project or presentation. So after the intervention, that did increase and go up. And writing about my thinking in math is helpful. At the end of the intervention, if they could pick, I think they would pick not to write about their math thinking. So again, that could be just a comfort zone thing. We use a composition book. That has been our way of doing it. This was the first time they did it digitally. And there were some issues with getting pictures in there, getting the cursor where they wanted it to be. So, maybe another question could be, would you prefer a digital math journal or a regular composition book to writing out your thinking? So, when they took their work, they practiced their worksheets. This is their worksheet average, and then they took the test. And a couple of students went from an 88% to a 30% on the test. So in many ways, some of them bombed the test, even though I had taught division using worksheets. There was a decline. These are the pre-intervention tests compared to the post-intervention test. And students who had done very poorly on the pre-intervention test did very, very well on the post-intervention test. So that data right there just tells me that 4 C's in technology works. And just some of the observations that I had that I wrote down in my journal is that students asked more questions and demonstrated a desire to understand the division. Even though the students were disagreeing with each other, their conversation was healthy. And learning was at times uncomfortable. As students created their movie, students were making mistakes. They were showing me their movie. We're done, look what we did. And I'd watch, and it wasn't division. So I'd say to them, this isn't division, you need to go back and work on it some more, let's talk about it. And again, this prompted a conversation with the teacher that was helpful for their learning.
This is some of my data analysis. I started with a question, and many students come to me thinking algebra is a lot easier than geometry. Algebra is about find x. Give us a problem, I'll find x for you. Geometry, you introduce pictures and they freak out. So before my intervention, I had about 20% or 13% that said geometry was easier. Post-intervention, in the agree bar right here, that went up. They did see geometry in a different way. Maybe that made sense to them. Introducing them to work in groups, to collaborate, to look at geometry in the world around them, help them understand it better. I would learn geometry better if I could collaborate with my peers in a group. There were some results that told, of course some of them strongly agreed, but the agreed went down. Some thought the groups were distracting. And at this point, some of them developed an introverted personality, and they'd rather not work with anybody at all. And but overall, I think the groups worked a lot better than they thought they did. Of course, writing is not part of math, and that's what they believe, and they believe that very strongly. Again, it's a matter of conditioning as they come to high school. They have never written in math, and introducing writing in math is something they were not comfortable with, and it was out of their comfort zone. But in my writing prompt, I did get some strong results. Some of them were, yes, pretty weak. But I think overall it does help to write, it helps them to write their explanations.
And just as a side note, the SBAC, which is taken by public school kids, there is a writing portion to the math test.
Right, and those are called
So-
performance tasks, where they will need to write to show their explanations about math. And my last question was about how to show learning. Again, my kids have come up through previous grade levels during worksheets and tests, and they would much rather get a worksheet for homework, take a test, and be done with, than to work with a project or presentation. My reflection, I thought it was an overall very positive experience. Collaboration worked great. Students were discussing rich conversations. Yes, there were some disagreements. A couple of times I had to intervene to make it less personal. But overall, I think collaboration worked really well. Critical thinking, we had self-discovery lessons, flip lessons. They had to think about how to solve a problem on their own without given direct instruction. Real-world connections through their project. And creativity, they had to show their project, communicate how they found their images, and make connections to outside classroom.
So in conclusion, I think that we would both agree that the implementation of the 4 Cs and the incorporation of technology do have an effect on the way teachers teach and student achievement. When students are taught with an emphasis of procedure and answers, test scores are lower than when students are engaged in 4 Cs and technology. 4 Cs and technology promotes higher level thinking, and the process of math, expecting collaboration and communication, engaging kids in creativity to create math scenarios or projects, resulted in students thinking critically. As we conclude our research project, some of the things that we've thought about for further research would be a continual effect of Common Core and what it has on student achievement and teacher pedagogy, especially since Common Core is so new. I had my students storyboard for their iMovie, and so I would like to learn more about how that affects student achievement. Learn more about digital math journals, and maybe there's some better programs other than Google Drive for students. And Navaz?
At my level right now, we are not, we don't have one-to-one technology. Actually, we have some students who may not have technology at home. So we kind of have to keep that in mind. So my goal would be to incorporate it more into my curriculum. Of course, they would have to use it in the library or the public library if they don't have it. But we are increasing our curriculum to include the technology. And I would like to research that more and how to do it.
So that was our research project, and if you have any questions or comments, it's you now.
What did the kids think about the process post? I mean, you're reflecting on the students. behavior and how their achievement rose once they've collaborated and kind of talked through the problems. Post the intervention, did you get any thoughts from your students?
Yes, that was the charts that showed the post-intervention, pre-intervention feelings about how
I guess
they
more,
taught.
I'm sorry, more specifically, would they want to continue? Did you ask the question, would you rather do it this way, moving on, versus not?
Right. I would say that, I didn't ask that question, but we are a one-to-one school, so, you know, we do movies and stuff like that. Sometimes kids, they just want to sit and do a worksheet, and I think they just want to turn their brain off. And I try to remind my kids that school is about doing hard things, and sometimes just working with a group is the hard thing that you're doing. So I think that would, I think there needs to be a balance. And I think that kids don't know how to articulate that, but I think that's what they want also. They want that balance.
In my experience, students really liked the collaboration piece. They asked for it again in my second lesson. They asked to do their reviews, they asked to do their homework assignments in a group. And they were happy to still stay in the group that I assigned. So they did get a positive response from that.
You mentioned that further tools that might complement the 4Cs implementation would be the use of rewards and accountability. And I would be curious to what that would look like at both your levels, really.
It's rewards for teachers.
Oh, okay, is that what it is?
Yeah, the teacher needs to well, according to the research, that when teachers are rewarded for using technology properly, that seems to have a positive effect. And accountability as well. And the research didn't specify exactly what that would look like, so that can be, I think, a touchy thing, how you're rewarding teachers for that kind of a thing. So.
I agree with the rewards, but the accountability at our level would be a big piece, because in high school there are some teachers who've been teaching the same thing for 20 years. And it's the change, and the whole change with Common Core has been resistant. So if they were given professional development, given the tools, and they need to learn the tools and how to use them, I think it would be beneficial.
Learning how to use the technology is important, but then teachers need training on how to incorporate it into their curriculum and time. Because it takes time to figure out, you need to be able to not only put it in your curriculum, but say this is my proof that this is 21st century learning. And it's not just go to Khan Academy and learn how to do this or that. I know some teachers use flipped learning and the kids just hate it, because it's just go home and watch an hour-long video. You know, and there isn't that come back to school and okay, let's talk about it. And it, you know, that's where you need the accountability of somebody coming in going, you're not using it properly, because it will backfire. The kids will not like to do it.
Again, I think there needs to be a balance. Flipped lesson every day, no. Once in a while or once a week, it would be a great tool. And in my school, I have been very proactive in trying new things. This last year was our first year to incorporate Common Core, but we knew we weren't really going to be tested as much. So there were many things that I tried. Why not? Yeah. And the kids were great. They loved it.
what are some ways that you think you could mitigate the time challenge when you're, especially when you're dealing with two of the 4 C's being collaboration and communication, particularly in your grade, in my opinion, in the lower grades, that you have infants in communication, and they're learning how to communicate appropriately.
Right.
And you get to a different level when you get to the upper grades. But you mentioned, Andy, that it's so time consuming. What kind of things do you think you could use to mitigate that to still be effective in teaching this process?
There are so many resources out there for teachers. You know, if I went, like she said, she found great videos on quadrilaterals. You know, she didn't have to think, how am I going to teach this? You just have to type in how to teach quadrilaterals for high school, and somebody's already created a video. So, you know, I think that helps me a lot. The Learn Zillion that I was talking about has been a great, and Front Row has been amazing resource for me. And then helping each other, teachers helping each other, I think is helpful.
But for the students specifically, I'm just curious, for example, you used the Skittle example. And so I saw some of them were struggling with consensus. So when they're not able to communicate and they can't build consensus, and you mentioned, so that becomes the time killer. So I was just curious how you mitigate that. I'm just curious. I love the idea of it. I'm just, it's got to be a time zapper in the classroom.
Actually, that did happen in one of our activities that I was doing. Students were given a note card with properties and nothing but that. And they had to construct according to those and identify which quadrilateral it was. And there were many arguments. But again, you know, that's part of real world. And they had to, some were raising their hand to ask me, and I said, no, you figure it out. You agree on something. And yeah, some were, did not like it, but that's part of what real world is going to be after high school.
And again, that's pedagogy. That's where's the teacher starting? Is she or he thinking, I have 45 minutes, or I have an hour and a half? Or is she or he thinking, you know, what's going to happen? I know that sounds very free, but that's a philosophy of education. You know, here's my plan, and here's what the kids need to know, and I'd like them to work on these math practices today. And there might be some great collaboration today, and I can use them as an example. Or there's going to be a lot of arguments today, and then we're going to talk about that and use that as an example. And I would also say that, you know, starting at the beginning of the year, you know, especially in the primary grades, you're training them to be in a group, to have conversations, to look at each other when they're talking. Third graders need to be told that everybody doesn't talk at the same time. You notice the girls, they were all talking at the same time.
Same thing in high school.
Yeah. So we have become so test driven. And I think that's what Common Core and the NEA is saying, is that this is about teaching kids how to be people in the real world, and getting that, or teaching them the process isn't teaching them how to be real citizens. So it can't always be about the answer. And I think that's what this is all about. And I think that the great benefit is that they did better on the test. It's like, wow, we're teaching them how to be thinkers, and their test scores are improving. It's a win-win.
Right.
Right.
And to that point, I mean, did you get any feedback from parents that, were they brought into the discussion at all? Did they say, wow, I didn't realize that would be the effect after?
I did not get any feedback from parents.
So the students didn't go back to their parents and say, oh, this is what happened?
No,
You
no.
never heard any feedback?
Yeah.
Okay.
No, neither did I.
Do you feel that this is equally successful for tactile as well as non-tactile learners? Well, that's
I think it
that's a
does.
layman's term for me. I don't know if that's a,
I think
No, I
it
know
does
what you mean.
combine a lot
because I'm a
of,
tactile learner. I
Right.
So.
it does combine the audio, the visual, the kinesthetic,
Mhm.
to look at everything in a different way, and to get all the both parts of the brain going,
Mhm.
instead of just getting direct instruction, okay, now I do the problems. Here's how you do it, now do 100 more and we'll move on.
Right.
That's not gonna happen anymore. Do 10 problems, but go in depth.
And I incorporated tactile lessons, and the only technology they had to do was take a picture of what they had done. So the kids who did the Skittles, you know, then they had to take a picture of that, and then they had to write about it.
Okay.
So, and I would imagine that Navaz has
Yeah,
hands-on stuff.
geometry is all about constructions and, you know, diagrams and protractors and straight edge and, you know, it's all self-discovery too.
One of my favorite subjects of all time.
That's my passion. I could do it all year long.
I think my question was similar to Dan's about, it surprised me in your results that kids were a little bit uncomfortable with collaboration. Because most teachers will say kids talk incessantly. So it's
Yes.
like they're so social that
Yeah.
I was surprised to find in your findings that they're a little uncomfortable with collaborating on an academic subject.
Right.
So I was wondering if you had anything that tips about how you made it more productive and less arguing, and you know, is there anything that you learned along the way that, hey, you know what, when I changed it up a little bit, here's how these collaborations were more effective?
It comes down to knowing your students in your class. There's one class in my algebra, one of my algebra classes, I would never use collaboration because they are just a different group of people. And if I did use it, I would have to front load with a lot of rules and a lot of, oh, okay, you can do this, you can do this, you can do this. You can talk about only these things and be respectful, you know, all these things that you have to front load before they collaborate. But both my geometry classes, I had no problems with collaboration.
The group that you saw, the project, that was a great project. That was my favorite one. That's why I showed it to you. But they argued, and they struggled with each other, you know, like this. They're three really bright kids, and so I would intervene and kind of act as the counselor sometimes. And when I introduced the project, there were jobs. And I don't always give jobs, but for this I did. There was, and they were simple, they were third grade language. The decider, you know, the writer, that kind of stuff. And I said, even though you might have a job, you know, you can still kind of do other things. But they, that was one example. Another struggle I had on the teacher end with collaboration were the kids who goofed off, you know, and like you said, they talk all the time. Well, you know, you're working with one group and then you realize they're not really talking about math over here. So, like she said, you got to front load, you got to establish your rules, you got to have your boundaries. So, again, I think when an outside person steps into this type of learning, they think it's very free and learn what you want and that kind of stuff. But there's a lot of boundaries and rules going on. And I think that's important to stick with those.
Another thing I found working with groups was I'm not teaching, and my classes are 40 kids each. I'm not teaching 40 kids, I'm teaching 8 groups. And that became a lot easier for me. And even if one person in that group understood, they communicated to the rest. So I was surprised, but I was happy about that.
I also find that when they're working in groups that you'll have, and we have these in our own lives as well, people who say, I'll just do it. You know, I don't want to take the time to explain my thinking or my idea to you, so I'll just do it. And to get kids to stop and go, no, you have to share your thoughts, you have to, you know, talk about it. Mm-hmm. Again, those are, in many ways, those are already ingrained in them. And so we're working on kind of molding that as they go through K through 12th grade. So, You know, it's okay to be that way, but when I'm in this setting, I have to be a little different. I have to be a little bit more transparent with my thinking, or a little bit more, okay, we'll do it your way, you know? So,
How do you avoid those introverts from kind of sliding by and not being active in the process? The ones that are not understanding the concepts, and instead of trying to debate it or slow down the process, they just go with the flow and they let it go. How do you deal with that?
I call on them to explain. And
And you kind of know those people
Right.
already, the introverts that
Right.
don't tend to get these
And
concepts.
you know these kids, you will know early on if they are introverts. So calling on them continually establishes comfort. Okay, she's not gonna call on me. I will know he knows the answer. So if he knows
Constant
the answer,
success.
that's the one I will call on.
Yeah.
And
you can see it in their eyes.
Right. And that
No.
establishes a little bit of comfort that, yes, I can give it a correct answer. So I can, and then they start raising their own hand. Then they start participating.
In the groups, I graded their iMovie based off a rubric. I also created a rubric that they were gonna grade. And they were gonna grade their own iMovie. And at the end, they got to rate their team members. And I, at the very beginning of the project, said, you know, you're gonna tell whether your teammates were participating, or, you know, and you're gonna actually rate them, like on a rubric. And I felt like that helped, because I could always point back to that rubric, because there were some kids who, that's just what they do. And so intentional conversation, you know, and observation. Teachers need to be watching. I noticed that you're not, you know, you haven't given any ideas yet, or I noticed that you don't have a job. You know, maybe you could draw the picture or something. You know, in 3rd grade, and high school too, I'm sure, you know, they need that
In high school,
direction.
everybody gets an A. Yeah, we were great.
And actually, when they graded themselves, they all graded themselves like they did an excellent job. So,
Even though they were arguing like
Mhm.
crazy.
But that's part
Yeah.
of the
That's-
process.
yeah.
The
It was.
arguments, the discussions, that is part of the process.
yeah.
And that's what we need to start.
Yeah.
I know a lot of teachers, okay, like a quiet class, so do I, but
Yeah.
I've stepped out of that just to listen to them.
So just for my own clarity, because you introduced the Khan Academy,
Mhm.
and I wasn't clear whether you, because you mentioned that they use some old school techniques that you felt that they were just reintroducing. So were you using them as an example, a positive example of the implementation of the
Both.
4C? Okay, I wasn't certain.
His philosophy is a good philosophy. Students should be at the center of their own learning. If they come into 3rd grade and they already know all their operations, you know, and they're ready for the next step, then they can go to Khan Academy and they can pick up where they are. And Front Row is kind of this way now also. And continue to learn. And if you've ever seen a video, it's usually the creator literally just on like a little
Like a little
digital
blackboard.
whiteboard or blackboard doing the math. You know, this is how you multiply, this is how you do long division. And it's almost like he's standing in front of the classroom with a chalkboard. So it is a traditional way of teaching. But his desire is, you know, that you obviously, I have 15 3rd graders, they're all in a different place in math. So, you know, I used Khan Academy, it's used, we've had 3rd graders use it before, but I think it's used as a resource for kids who are in junior high school, who don't understand this concept. They can go into Khan Academy, how do you do this or that? He'll explain it to you. So,
I've had my algebra students go in Khan Academy just to get their basic skills up. When they come into algebra, I'm not teaching them how to multiply or divide. And I'm not teaching them how to do the basic skills. They need to get caught up on that, and I was signing content lessons for that.
Would you say that they're a successful model then of implementing complementary techniques? Or,
Yes and no. It is still procedural,
okay,
but sometimes that's what's necessary to get kids caught up.
He's not going to talk about real world situations.
Right.
It is.
He's not gonna
definitely-
present them with a problem and say, now what's the answer?
Right.
Yeah, he wants to get kids, he loves math. He's a mathematician. And so he's over there in that world. And he wants to help kids who are coming into algebra and they don't know how to do these basic functions. But then he's also there to help the kids who are like, I'm bored, you know, I know how to do all of this. So, but Front Row takes it a next step and does do more concepts. Here's the situation, what's the answer?
And those are the problems they'll see when they start taking the SBAC for the state.
Right.
interesting.
Any other questions? Well, thank you so much.
I appreciate
For
it.
sticking
Thank you.
around.
Presentation, you guys were awesome.
Oh, thanks.
That's a really interesting study.
Thank you.
Oh, good.
Yeah.
I'm glad you were interested.